Hello YouTube. Alright, so I'm going to show you how to do quick sort in C Sharp. Right, so there are other options out there, but I wanted to show you this in C Sharp. Alright, so I'm assuming that you already know what quick sort is. You have some knowledge for algorithms. So I'm assuming you just want to be here to learn how to do this with C Sharp. So let's get started. I already have the basics here. I have my unsorted list, and quicksort pretty much what it's doing is just trying to sort a list. And what it does, it uses a pivot. So it just grabs so that you can grab a random number, and then there is a condition that checks if anything that is less than your pivot, you put it on the left list. Anything that is greater than the pivot, you put it on the right list. And then you call yourself recursively until you get a single list or single array. So you keep calling yourself and you keep doing halving yourself and all the way until you get to one item list. One item list is already sorted, and then that's at the deep end of the stack, and then you keep sorting, and then you kind of uh, you're gonna be doing a comparison. So at the very end you're gonna be doing a comparison, and then you're gonna start sorting yourself as you unwind back. It was a little bit difficult to understand at first, but trust me, use Visual Studio, use this code, play with it, put breakpoints until you understand it. All right, so let's get started. So the first thing you want to do is we're passing this unsorted list, passing it here, and the first check we're going to do is we're going to do a check to see if the list count or the length is lower or equal to 1. Because the value 1, if you have a list that has a value of 1, that means it's already sorted. So that return the list, right? So that's your main that's your base check. That's once you get to that point, that's when you stop and you return the single list back to the caller, right? So from here, we're gonna create left two lists. The first one is gonna be var, so it's gonna be less than pivot equals to new list integer, and then you're gonna create a var more than pivot equals new list int. Say that, and we already saw that error here. I don't understand why. Okay, this is return list. Okay. Then, so we have the list, the left list, and the right list. The list that is less than pivot and the list that is greater than pivot. And then we're gonna have the pivot value. Now, like I said, you can select a random value from the list and then work from there. So you grab that random value, then you compare. Is all the values less than this? You're gonna assign it to the less list. All the values greater than this, you're gonna assign it to the right list. But a lot of people, what they do is to make it easier when you're learning how to do quicksort is they assign pivot. You use the first index. You use the first value in the first index, which is index 0. And you should do that if you're starting because it's easier easier to follow. So I am going to use that. So I am using the list, the value on index 0, and I'm going to assign that to the pivot, right? And then from here, what I want to do, if I can remember, let's see, not remember, let's figure this out. So I think we need to make a check. So if we do if list, let's think about it. So here, okay, so I was just trying to, so we have that, so we have to, all right, so we need to think about this. So we need to iterate through every single item here except the first index because that's what we have the pivot. So we need to iterate to every single value on the right side. So we're gonna do a loop. So we're gonna do for int I equals 1, right? Because we're gonna equal that to 1 because the pivot is on index 0. So I is lower than a list that count, then I increment that. We're gonna do this. That will work. We'll work it out. All right, here, what we're gonna do is we're gonna check on, so we're gonna start iterating from index 1 and forward. And then we're gonna assign on the first iteration, we're gonna assign the current value to a variable. So it's cur value equals list the value on index I. So this will give us the current value. Then we're gonna do if, because we want to get the current value, so we're gonna get this value here. And then we're gonna say, is this value less than the pivot, which the pivot is 9, or greater than the pivot? So this is greater, so we will add it. We will add it to the less less than pivot list, or to the more than the pivot list. Okay, so let's do the check. So if current value is lower than pivot, then less p that add, you get current value. Else more add current value. Make sense right now? So we're iterating through the remaining of this, and then we're just assigning. So if this is greater than this, we'll assign it to the right pivot. If it's lower, we assign it to the left. So we're grabbing this, and we're gonna iterate through the remaining, and everything that is below 9 is gonna go to the left. Anything that is above 9 is gonna go to the right. Make sense? All right. So once we're done, kind of distributing the values like that on the first pass, then we are going to we're going to call ourselves again, and we're gonna pass the ourselves, we're gonna call ourselves again with the new list. We're gonna call ourselves with a list that with the values that we place on the list less than pivot, and then we're gonna call ourselves again with the values that we placed on more than the pivot. And we're gonna continue going through that until we arrange all the numbers. So let's do that. So, but every time we call ourselves recursively, every time you return, you want to store it somewhere. So which you need to create a list where you're gonna store all your items are sorted. So for that, you're gonna create another list. So let's create a bar sorted list equals new list integer, and then here we're gonna add a range. So in this situation, we add a range because we add a collection, which is in this case, a collection is just another list. But here we're gonna call ourselves inside this method. We're gonna call ourselves with the less than pivot list or collection. And this is a recursive call. So you're gonna be calling yourself over and over again, and you're adding that to the final list, which is the one that we're gonna be returning at the end. So we already took care of the left side of things for everything that is getting stored on the left side, and then the pivot. So since with the pivot is the value that we use to assign left items and then right items. So it makes sense that we start with the left items, then we add the pivot, which is we do sorted. Is that add, since this is not a collection, it's just the value that we assign here, because that's our midpoint. That doesn't change because everything is getting assigned to the left or everything is assigned to the right. So that one we just added. And if you notice, we are in this sorted array or list, we already took care of everything on the left, which is sorted. So everything below 9, it should be sorted already. So 1, 2, 3, 4, 5, 6, 7, all the way to 9, or whatever numbers they are. Then we need to take care of everything greater than the pivot. We need to add them to the final list, which they should be sorted by calling yourself again. You should sort them. We should sort them again. And that's how you get a complete sorted list. But instead of passing less than, we do more p. And then at the very end, we return sorted. And I think this is it. So you can take a look at this. This is how you do quicksort C#. Let's test it. So we're passing this. If you notice, the pattern that I use over here is unsorted, but it's pretty much is 1 through 14. So you will see it when I run it. And all these weird numbers, this is just, it's pretty much is whatever we're writing using this right line. This is just for you to kind of see what we're doing, how we're breaking stuff down. So from the big list, we just started with the left side, and then we start breaking stuff down until we get to single items. If you notice here, this is the final output. The final output is a sorted list 1 through 14. And if we add, let's add something else to spice this up. Like let's do 100. Let's do 100. Let's do 400. And then let's do 150. Let's run it again. You see, it sorts everything. 14 or 100, 150, 400. So it's doing its thing. I just like to keep it up to the 14 because it's easier to read. All right, so I really hope this is useful. Thank you for watching.